In this lesson, we're going to look at electrical circuits. We're going to begin by looking at the parts of a circuit, followed by the types of circuits, and then we'll finish up with some practice problems. Now, you might be thinking to yourself, when will I ever need to know this? Well, in this lesson, you're going to be learning the fundamentals of electrical circuits, which will absolutely help you out someday when you perhaps own a home, or even when you rent a home. Understanding the fundamentals of electrical circuits can save you some money. If you ever have to troubleshoot an electrical issue in your home, you won't have to have an electrician come out and do it. Might even be something simple that you can fix yourself. So understanding the basics of how these circuits operates will definitely help you in the future. All right, let's begin by looking at the energy source. This is probably the most important component of an electric circuit. It provides the voltage and current. So this could be a battery, it could be a solar cell, it could be the power coming in from the outlet in your wall. This supplies all of the voltage and current to the circuit. Now we haven't defined what voltage and current are yet, but when we do, you can think back and understand that the energy source is what's supplying that to the circuit. All right, the conductor provides the path in an electrical circuit. This is where the energy flows. So this is the wiring in your home. And typically in a circuit, it's just some sort of wiring. So the switch provides control over the energy flow. When we close the switch, it allows the flow to continue. It allows the electrons to continue through the circuit. When the switch is open, as it's shown in the diagram here, that breaks the electrical flow and does not allow the flow to continue. So think about your light switch. When your light switch is turned on, it allows the energy to flow through, so that would be closing the circuit, or closing the switch rather. And then when we turn the lights off, we are breaking the circuit, which does not allow the energy to flow through the circuit. And finally, the load is any device attached to the circuit. When activated or energized by the flow of electricity, you get something like a light bulb turning on. Now the load is the amount of energy the device uses to complete the task. So again, think about a light bulb. How much energy is that light bulb using to be a light bulb, to turn on? Other examples of loads could be motors, could be LEDs, which is another type of light bulb or something similar to a light bulb. You've got your computer at home, speakers, your phone when it's plugged into the wall could be a load. So pretty much a load is anything that's attached to a circuit. Okay, so there are two types of circuits that you need to know. The first is a series circuit, and it's arranged in a chain, like our picture here. So we have three loads that are attached to our circuit here, and it's one right after another. So a series circuit is kind of like that lazy river example. At a water park, you just kind of flow in a circle. Charge only has one path to take here, so it just kind of moves in a circle, or kind of like a racetrack. So only one path to take. So series circuits are used nowadays as more of a safety mechanism. So if you have a space heater, obviously we want that to shut off if there's a problem. So in a space heater, there might be something to break that circuit. So on the space heater that I have, when the space heater tips over, a switch is open, which turns the space heater off. Obviously, we don't want the space heater to continue heating. If it were to fall over and, let's say, face a carpet, that could cause a fire. So nowadays, you'll see something like this in devices like space heaters as a safety mechanism. All right, parallel circuits are much more common than series circuits. They have multiple pathways for the charge to follow. Now, even when one of the paths is broken, the circuit continues to operate. So your home, for example, is wired in parallel. Like when you have a light bulb go out in your house, like all of the lights in your house don't stop working, they continue to operate. So parallel circuits allow that to happen. So this is a wiring diagram from a house. This looks like it might be from a bathroom because we've got a tub here, a toilet and a sink, and then I see a ceiling fan. So this is something typical that you might see in your house, and being able to understand how this circuit is arranged and what all the different symbols mean is definitely important. So if you have to hunt down an electrical problem in your house, being able to kind of make sense of a diagram like this is important. So we're going to be doing two practice problems here. We're going to use the Circuit Builder PhET to construct a couple circuits. So the link is down in the description for this video. So our first example, I'd like you to create a series circuit of a light with an on-off switch. So you can go ahead and pause the video, and when you're done completing the circuit, go ahead and unpause the video. All right, so hopefully by now you've had a chance to play around with that. And when I created this circuit, I had something that looked like this. So in the picture, you can see I have my power source right here. Here is my switch, and then here is my light bulb. And as you can see from the picture, my light bulb is on. All right, in this next example, I'd like you to create a parallel circuit with two light bulbs and a switch that turns both light bulbs off at the same time. So as before, go ahead and pause the video, and when you are done, come back and unpause the video to see the solution. All right, hopefully by now you've had a chance to go ahead and create that circuit. Let's take a look at my solution. So as you can see, I've got my switch here before the two branches. I've got a branch here with one light bulb, and I have a branch here. By placing that switch before the two branches, when I open the switch, it does not allow the energy to flow to the two light bulbs. So it's important that that switch is placed before the branches for the circuit to operate as intended. And that concludes our lesson for today. We discussed the various components of electrical circuits. We talked about series and parallel circuits. And in our next lesson, we will take it a step further by defining some of the other terms that are needed to understand circuits.